Hey guys, Mrs. Stans here. Lesson 4 of our statistics unit. First of all, I just want to point out some things that I didn't like about the homework before I forget to tell you. So if you turn to where your homework is, starting here on page 18, right here, number 7 and 8 really is one question that for some reason got separated. You can't answer question 7, there's not enough information. So really these two questions go together. And then question number 9 is a bad question. There's not enough information, so you don't have to do number 9. And then this table here actually is not part of number 9. I guess we could call this one number 9, A, B, and C. And then this is fine. So if you could just fix that so that you're not confused when you're doing your homework. So our objective is that we're going to be using the mean, median, and mode as types of averages. It helps us be able to say something about the set of data that we have in front of us. And I'll go over the do now with you, and you should check yesterday's homework answers. They were provided in the assignment. And we will do the development together, and then you'll do the problem set on your own. And by the end of the lesson, you should know what mean is, median, and mode. And again, you do need your calculator for this lesson, so make sure you have it. So here it's just, I'm going to reword it in my own words, just talking about when we gather data, we really want to be able to talk about it. And we usually like to talk about the average. And a lot of you, when you hear the word average, you think about adding up the numbers and dividing by how many there are. That's how we do average of your test grades. But that type of average actually has a particular name called the mean. Mean is when you add up the numbers and divide by how many you have. But there is another type of average called the median, which we've been talking about with our box plots. The median is the middle number in a set of data. The median, a lot of times, is a better teller of the information than the mean if there's an outlier. So if you remember when we were in school, anytime that I would tell you the average of a test, I would also tell you what the median was. Because if there was an outlier, if there was like an extra low grade, or an extra high grade, it throws off the mean. It gives like a false impression about what the class average was. So if there's outliers, usually the median is the better average to refer to. And there is one other type of average called the mode. The mode is the number that happens most often. So depending on what kind of situation you're in, I guess depends on what type of average you're going to use. Like I said, typically with grades, we do the mean. And then if there's an outlier, the median is a better teller. And mode is for particular circumstances. Like imagine if you were someone who owned a shoe store, right? You want to have enough shoes in stock so that when people come in, they can get their shoes. So you'd like to know like the average size of a person's foot so that you can have more of those in stock. So typically the store owner is not going to use the mean. It's not going to add up all the people's feet and divide by how many people they see. And not going to use the median either. Probably will use the mode. Like what size shoe is bought most often? Oh, let me make sure I have that shoe in stock. So that's a case where maybe mode would be a type of average that we would use. So let's do exercise 1. So there are 12 people. Surveys taken amongst 12 people on a number of passwords they currently have to remember. And the results are shown below, and it's already in order. They want the median number of passwords. So if there's 12, 1, 2, 3, 4, 5, 6, right in here, between 2 and 3, so 2.5 is the median. And they're asking for the mean. So remember I said the mean is when you add up all the numbers and divide by how many you have. So you can go ahead and add up these numbers. The numbers are so small, we could probably even do it without a calculator. This is 10, 13, 16, 19, 20, 22, 23, 24, 25, 26, 27, 28, 29. So I just got 29 that we divide by 12 because there's 12 pieces of data. You could use your calculator on that, but you get a 2.4. So the mean happens to be a little lower than the median. I want to show you on your calculator, well actually I showed you the other day, that you can enter your information into stat in your list 1, and if you enter that information, after you enter the information, if you go to stat over to calc, 1var stat, your calculator, mine remember isn't as updated as yours, so your calculator I think has a few other things here. It'll say, oh, let's go to here, your calculator will have stuff like this. It'll have list and it'll say L1, and then the frequency list might have nothing there, and then you have the word calculate. So you guys have to move down to the word calculate. I didn't mention that in yesterday's video, and I hope you figured that out. You move down to calculate and hit enter. My calculator's just not as updated as yours, that when I hit enter, it just automatically does the calculations. So this X with a bar over it stands for mean. So the mean is 2.4 rounded to the nearest tenth, which is what I figured out before. And remember, if you scroll down, the median here is 2.5. So just a reminder about how to use your calculator. Mean is an X bar. I want you to remember such a thing so that you could use your calculator better. And like I said, on your calculator, you have to move down to calculate and hit enter. Number 2, some people mess up on number 2 because of the way that the table is displayed. So the students are trying to determine if people's speed along a certain section of the roadway. So they collected the speeds of 20 vehicles. That's so important for you to recognize that there's 20 vehicles, because when you look at this, it doesn't look like there's 20 different numbers. But over here it tells you how many cars were going that speed. So really, 29 happens once, but 33 happens twice. 34 happens 4 times, 35 5 times, and so on. So these numbers don't just happen once. These speeds don't occur one time. They occur multiple times, and the number of times they occur is in the second column. So if we're going to use our calculator for this, there are 2 ways that you can do it. This might be the easier way for you, especially since my calculator's not updated. I can't show you really the other way. Well, I guess I can, but let's go for this. So we're going to go to edit. I'm going to clear my numbers in L1, and I'm going to enter 29, and then I'm going to enter 33 twice, and 34 4 times, 35 5 times, 36 is 3 times, 38 is 2 times, 39 is 2 times, and 54 is once. 20 numbers were entered, so I'm hoping I didn't make any mistakes. I go to Stat, Calc, 1var Stat, and you move down to Calculate. I'll hit Enter, and I could see that the mean is 36.1. And the median, if you scroll down, you get 35. Now, I had said that there was another way you can do this. Again, I'm going to show you those notes right here. In your L1, we could enter this number, the speed of the car, and in the L2, you can enter how many times it occurs. And then when you go to your 1var stat, you're going to make sure your list says L1, and then your frequency list says L2. Your frequency list tells you how many times that number happens, and then you hit calculate. I can do it also, even though I don't get those numbers. I'll show you what I can do on my calculator. So we're going to edit our list. And I'm going to enter just the speeds as I see it in my L1. 29, 33, 34. I'm not entering it multiple times this time. I just want to show you get the same answer. This way, though, sometimes is a bit trickier. So you don't have to do it this way, but you don't have to enter the numbers as many times either. So now I'm going to go over to my L2, and next to the 29, I'm going to make sure I have a 1, because 29 happens once. Next to the 33, I'll put the 2, and so on. Now, when I go to Stat and Calculate, still a 1var stat, still one set of data. It's just that I want my list to say L1. So do you see above number 1, in blue it says L1. Above number 2, you see the L2. Above number 3, you see the L3. So your list should say L1. I'm going to clearly specify that the first set of data is in L1. I have to put a comma. You're going to go to the frequency and make sure it says L2, and then you're going to move down to calculate, and you can see that I get the same answers. I have 36.1 as my mean. You can see that this N is 20. There really are 20 pieces of data, even though I only entered it once. My median is a 35. So I get the same answers. You could do it either way you choose. Just get the right answer, of course. So the speed limit along this part of the highway is 35 miles per hour. And based on your results from Part A, is it fair to make the conclusion that the average driver speeds on this roadway? So some people say, ooh, you know, the mean is greater than the average. Oh yeah, the average person does speed. But there was an outlier, it looks like that speed of 54 is awful high, right? And it threw off the mean a bit. It brought it a little higher maybe than what it really is. The median is 35. So that would mean like half the number of people go the speed limit. We could even see that really all of these people go the speed limit or less. 9, 10, 11, 12 out of 20 people don't speed. So I wouldn't say that it's fair to say that the average driver speeds. Actually, no. The average driver doesn't speed. The outlier of 54 raised or increased the mean, really 12 out of 20 people don't speed. So you have to look at data as a whole. Now we're going to be talking about when we take a survey and whether it's like a fair survey or not. When we take a survey, usually we're using a sample of the data. That means you don't ask every single person. If I wanted to know in our school, you know, how many people do their homework every single night, I might not want to go around and ask every single person. I might want to ask a small group of people, see how many of them do their homework every night versus how many who don't, and then hope that that sample I took refers to the whole population. So that's what statistics is all about. We don't usually survey everyone in the world. We have to take a small sampling and hope that the sample that I chose represents the rest of the people properly. So that means that you have to take a fair sampling. If I wanted to know about that homework situation and I went into my accelerated classes, you guys, and asked how many of you do your homework every night, um, I have to tell you that usually accelerated students do their homework more often than maybe some other types of students. So it wouldn't be fair of me to go into an accelerated class because you tend to have maybe a better work ethic than other people. Now, please don't think that I'm putting down my other students. I have some great students in my other classes. I'm just saying going to an accelerated class wouldn't be a fair sample. Also, if I just go to an 8th grade accelerated class, I'm like leaving out the younger kids. Maybe the 6th graders and 7th graders aren't as mature and haven't realized that doing homework is really very important. So maybe a better sample, something that would maybe be more fair, would be waiting outside the school as people are walking in and maybe ask every 10th person who walks in. So hopefully, as I'm waiting to see people walking in, there'll be some 8th graders, some 7th graders, some 6th graders, some kids that are in accelerated classes, some kids that aren't in accelerated classes. It would be more of a fair sample because it's like random. Every 10th person walking in the building is more random than going into a particular classroom. So on number 3, to determine which television programs are most popular in a large city, there was a poll conducted. And which one would be a most fair sample? Standing outside of a baseball stadium, standing outside of a concert hall, standing outside of a grocery store, or standing outside of a comedy club? Which one would be most fair? I would say choice 3. Now, would there even be a better sample I could take? Maybe not standing outside of a store, maybe, I don't know, someplace else. But you don't want to stand outside of a baseball stadium. Those people love sports, so they might be watching sports more often. If you stand outside of a concert hall, those people are more into music. If you stand outside of a comedy club, they might, like comedy type movies. But a grocery store, we all eat, right? So people who like sports, people who like music, and people who like comedy all have to buy food. Number 4. So if we're trying to determine the average height of high school male students, they want to take a survey. So he's on the basketball team. So he uses heights of the 14 players on the team. So right away, I'm already thinking this isn't a fair survey. If you want to know the average height of a male student in a school, you don't go to the basketball team, right? They all tend to be pretty tall. Usually basketball players are on the taller side. So he already has a biased sample. Um, but they do ask me to calculate the mean and the median for the set of data, and we have to round to the nearest tenth. So why don't you figure that out? I already figured it out that the mean is 74.6 and the median is 74.5. So is the set of data fair? And I would say no, because of what I said before. Basketball players tend to be on the taller side. And if you're trying to find the average height of just a high school student, you don't go to the basketball team. So we already talked about outliers when we were doing our box plots. In Mr. Petrovic's advanced calculus course, 8 students recently took a test, and the grades were as follows. Calculate the mean and the median of this set of data. So, I want to enter this into my calculator. I don't want to just add it up and divide because I'm kind of seeing what's coming next. In part B, they're asking what scores an outlier. Remember, on our calculator, the one place we can see outliers is in our box plots if the whisker is not attached to one of the points. So I do want to enter this data into a list so that I can also look at the box plot. If you didn't want to enter it into the list, then you need to remember how to find an outlier. Remember, it's 1.5 times the interquartile range. So still you need the upper quartile and the lower quartile to subtract those to get the interquartile range. And then you'd have to multiply by 1.5. I actually think it's just way easier to enter it into the list. Clear out both L1 and L2, please. You don't want anything in your L2 because your calculator will use it as the frequency. And there's only one set of data here. We don't have to worry about a frequency column. So I just entered 8 pieces of data. That's correct. So stat, calc, on var stat. And I could see that the mean to the nearest, does it tell us to the nearest something? Calculate the mean and the median. Nope, so I'll just write down what I see. 71.75. Did I enter that right? When I did it on my own, I found a different answer. I'm going back to look at my list. 45. Aha. Do you see this? Did you all notice it? I missed the 8 when I was typing it in. 82. You might have known I made that mistake and I didn't see it. But I think I have it now. Mm-hmm. 81.75. And the median, if you scroll down, you get 86. To see if there's an outlier, if there is one, I bet you it's the 45. To see if there's the outlier, let's go to stat plot. Let's make sure we're using plot 1. They're turned on. We are going to go to the box and whisker that shows outliers, and we're going to go to zoom, and then since this is statistics, move down to 9, and I see that there's an outlier there. You remember you can hit trace and move your cursor, and that's the number 45. And that's the only point floating out there without a whisker attached to it, so 45 is the outlier. We could have guessed that's what the outlier was, but it's good to check it out. Which value, the mean or the median, is a better measure of how well the average student did on his quiz? Well, I would say that the median is better because this low score of 45 brought down the mean. If you look, since there's only 8 numbers, you can carefully look and see that really more than half the students got 86 or higher. A lot of times when we see median, we say half of them did above an 86. Well, half of them did get above an 86. I guess more than half the students got above the mean. Half of them did get above an 86. So I would say that the median is really the better teller. Now this is some problem solving. So the average of A and B is 6. So if A plus B divided by 2 is 6, that must mean that the sum of A and B is 12, right? Because 12 divided by 2 is 6. I usually write it as an equation like this and think about like these cross products. That 2 times 6 tells me what the sum of the numbers is supposed to be. The average of X, Y, and Z, this time I divide by 3 because there's 3 numbers, is 16. That would mean that the sum of these numbers, remember that summation symbol, the sum of those numbers would be 16 times 3, 48. So they're asking what is the average of A, B, X, Y, and Z. So I want to add A plus B plus X plus Y plus Z and divide by 5. Now I don't know what each of these numbers are, but I do know that the sum of A and B is 12, and the sum of X, Y, and Z is 48. So the sum of 12 and 48 is 60, and 60 divided by 5 is 12. So the average of those 5 numbers would be 12, even though I don't know what each number actually is. You cannot just do the average of the 6 and the 16 and think that you're getting the average of all 5 numbers. The average of 16 kind of outweighs the average of 6 because there's like 3 numbers here giving you an average of 16, where this is only 2 numbers giving you an average of 6. So since we're comparing like different amounts of numbers, you can't just add the 6 and the 16 and divide by 2 or divide by 5. Like none of that works. You have to have the sum of all 5 numbers and divide by 5 to know the average of those 5 numbers. In B, the average grade on a test taken by 20 students was 75. So there are 20 students divided by 20 whose average is a 75. So I can find the sum of these 20 students by doing 75 times 20. don't really need my calculator for that. I know this is 1500. And then one more student took the test. So now I have like the sum of the 20 students, which is 1500, plus one more kid. Since it's plus one more kid, now I'm dividing by 21 students, and the average became a 76. So it increased the average by 1. What did that one kid get? So why don't we just see what the sum is supposed to be of those top numbers. 76 times 21 is 1,596. So we had 1,500, and now it became 1,596. That must mean that this one kid got a 96. So that one student received a 96. He needed that high score in order to raise the average by 1 point. On C, they're telling me that J is above 0, which means it's positive, and they want to know the average of these. So it's like our polynomial unit. This monomial plus this binomial plus this monomial divided by 3 gives me the average. So really I'm doing 2J plus 4J minus 3 plus 6 divided by 3. Combine like terms, 6J plus 3 divided by 3. This denominator of 3 has to divide into both parts of the numerator to get 2J plus 1. The sum of an odd number of consecutive integers, so like 3 integers, 5 integers, has to be odd, but the sum is 0. So if I add these, I get a 0, or if I add these, I get a 0. They're asking what's the median, so they want to know what this middle number is, or what this middle number is. It really doesn't matter if it's consecutive integers, and it has to add to be 0. This middle number must be a 0, because this would be like a -1 and a +1. This middle number has to be 0. I'd have -2, -1, +1, -2. It's the only way it could give me a sum of 0. On E, create a data set of 7 integers in which the median, this number right here, is greater than the mode. So there really are an infinite amount of sets of data I can create. Pick a number for the median, like if I pick 10. The numbers to the right of it have to be greater than 10, and the numbers to the left of it has to be less than 10. And they want the median to be greater than the mode. Mode is a number that happens most often, so let's make a low number happen most often. How about like 5, 5, and 5? Now the mode is 5 because it happens 3 times, and let's not make anything else repeat. And there we go. We just made a set of 7 numbers in which the median is greater than the mode. And then you have your homework. So I'll talk to you soon. See you. Bye.